Hello, so what we now need to look at are the uses of the generator effect. Right, now you can't use the generator effect to cheat the laws of conservation of energy. So let's give an example. Last time round we talked about how moving a magnet into a solenoid would make a current. Okay, now the brighter ones who have watched this video, or the extremely clever ones who have watched this video, thought, right, okay, can't we do that in a manner where you've said that pushing that in makes a current? We know that a current in a coil produces an electromagnet, so can't we shut the magnet in the same way that makes that into a south pole, so that gets accelerated, because we know north and south attract each other. You can't do that, that does not work in terms of the concept of physics. Otherwise, what you would do is you'd get a magnet, you'd get all these coils lined up, and then you'd permanently accelerate something past speeds of the speed of light, which obviously can't happen. So what actually happens when we induce a potential by moving the magnet inside the coil, this will generate a north pole at this end of the coil, and that opposes the motion of it going in. So it causes a decelerating, retarding force of it going in. So you move a magnet in, yes, it will induce a potential, yes, it will induce a current in that, it's part of a complete circuit, and therefore a magnetic field will be induced, but that magnetic field will always oppose the motion. So if we put a north pole in there, then that will turn into a north pole and slow it down. If we put a south pole in there, that will turn into a south as well. The key sentence for this is, if there's an induced current, it generates a magnetic field that will always oppose the original change. It will always oppose it. So that will make the north. If you put the south, that would make the south. When you do A-level, this is known as Lenz's law. I have made a Lenz's law video for those who want more detail. Right, okay. So moving on from that, what we talked about is how, if we cut through magnetic field lines, that induces a potential difference, and if it's part of a complete circuit, then current will flow around the circuit. So if we have a north and a south, and we've got a coil spinning round, then what happens is that will make a potential difference. If we want to increase that value, we could get the coil to spin faster. We could increase the magnetic field strength, which is why power stations actually use super electromagnets with high magnetic field strengths to generate a higher potential difference. Or we could increase the number of turns on the coil. That would also correspond with increasing the area of the coil as well. If we wanted to reverse the direction of the induced current moving in, we'd just send the coil spinning around the other way, or we'd reverse the polarity of the magnets. And what I mean by that is we put the south there and the north there instead. Take care not to use the term turn the magnets around, okay? This is me turning round. Yep, I'm still facing in the same direction after I've turned round. Turning round is a vague statement. It does not convey 180 degrees or 360 degrees. You are just saying turning round. Right, so the practicality of this leads on to generating alternating current. So, because these are consistently changing direction, okay, the direction of the potential difference generated changes. When it's perpendicular, we get maximum voltage. When it's parallel at 180 degrees, we get 0 voltage. When it's 270 degrees, so if it's turned around, see what I did there, then you get voltage maximum in the negative. And then once it's parallel again at 360, slash 0, because they're the same thing, okay, then you get 0 again. So what you get is a sine wave. So if we get it spinning, then what happens is we get voltage generated in that manner. If we get it spinning faster, not only will the waves be closer together, but they will peak at higher values because you have increased voltage. So if you get a grade 9 question asking What happens if you get it spinning faster, draw the graph? You need to have higher peaks and lower troughs, and you need the waves closer together. We've already had a look at the dynamo when we've talked about the bike on a past paper question before. Okay, the dynamo is for direct current, and that's because it's got a split ring commutator to make sure that the current is reversed every half turn. It's got slip rings, which you no longer need to know about, it's not in the specification, but that's to stop it from tangling. And it's got the graphite brushes. Graphite is a conductor of electricity, and it's the contact between the commutator and the coils. And those are the uses of the generator effect.